All right, so this time we just want to consider our variation concept that is from our Zimsec tropical collection. Yes, that's variation. So we have a lot of questions actually here, a lot of questions that we are going to focus on, a lot of questions that can help us to understand our variation techniques. How do we play around with variation? It's one of the most important topic that we have, one of the most important topic that you're going to consider, carrying a lot of marks from paper one, and also we expect to have variation in paper two. I explained from the basics of our variation. All that we need is to know the types of variations that we are going to consider, considering the direct variation, whereby we are referring to two variables that are being connected by a constant in this manner, A varying directly as B. So this is how you present a direct variation, A varying directly as what? As B, or A is directly proportional to B. That's a direct variation, whereby you introduce the constant and it's going to be A is equal to KB. These are the steps that you need for a direct variation. A varies directly as B. A is going to be equal to KB, where K is a constant to be found in this case. Then we also have the second one, which is the inverse variation. So we've got the inverse variation from the word inverse. Remember, inverse of a number. The inverse of a number, it's 1 over that number. All right, the inverse of 2, it's 1 over 2. So the moment we talk about inverse variation, we must be thinking of the 1 over concept. This 1 over concept, that is the one that you're supposed to be thinking of, because we are referring to two variables that are inverse to each other. So in this case, we are going to have A varies inversely as B. A varies inversely as B. That's 1 over B. Inversely as B. This B, it's 1 over the inverse of B. Remember, I said the inverse of a number is 1 over. So if you say the inverse of B is going to be 1 over B, that is the inverse of B. So whenever we are dealing with an inverse variation, it's going to be 1 over that part that is inverse. Then we introduce the constant. So A is going to be equal to K over B in this case. So this is what you're going to have from K times 1 over B. This is same as over 1. So K times 1 is K, 1 times B is B. So at the end, under our inverse variation, this is what we are going to have at the end. We are going to have two parts A and B connected in an inverse way, then with a constant to be found. So the K there is the constant to be found. We have to calculate that constant. Then we have the joint variation. In this case, we've got joint variation. So a joint variation is a combination of two variations. So we can have a combination of two direct variations. We can have a combination of two inverse, because we are joining two variations here. Or we can have a joint variation of a direct and inverse at the same time, direct and inverse variation, whereby you are connecting something that is direct and something that is inverse. So these are the parts that you expect for a joint variation. You can expect these this direct variation that we see, two of them connected together, or the inverse connected together, two of them. So in this manner, remember, this is how we have as a direct variation. You say A varies directly as B is going to be written this way. So if we have got a condition of two variations in which are connected under direct variation, we are going to have a condition like A varies directly as B and C. A varies directly, which is jointly as. Directly from the joint variation, A we are asked, we are given A varies jointly as B and C, like that. They might not mention to say direct, they just say A varies jointly as B and C. Those variations, they are connected together in direct variation, as direct variation. So that is what you're going to have. And at the end, we introduce the constant, just like the previous part, Ka is equal to KBC. So this is what you're going to end up with, where K is the constant to be found. A, B, and C are the variables that you'll be given their values. All right. So here it's a combination of two direct variations in this case. But like I said, we can have also a combination of two inverse variations under joint variation. Like this part, remember, this is our inverse. A varies inversely as B. So we are going to have A varying inversely as B and C at the same time. A is varying inversely as B and C at the same time. So it's a joint variation. There are two inverse. It's A is inverse to B, A inverse to. So A is varying inversely as B, inversely as C. A is varying directly as B, directly as C at the same time. So there are two variations. These are variables A, B, C. These are variables. K is a constant. A, B, C. These are variables. Variables, we're just talking about letters to be considered. Letters to be considered, not constant. A constant represents a certain value which does not change. While the variables, they change. You'll be given any value at a particular moment, but the constant does not change. So K there is the constant, whereby we are supposed to introduce the constant. So A is going to be K over BC. This is what you're going to end up with in this case of 2 inverse. And like I said, we can have a combination whereby we are connecting two, we are connecting a direct and an inverse under this same joint. We'll be having A connected to B in a direct, but to C it's connected in an inverse way. It does not mean that we are going to have the same concept throughout. No. It can be a condition of A is direct to B, but when it comes to C, it's inverse. That's a direct and inverse. So at the end, we are going to have a condition like this. A varies directly as B. A varies directly as B. And inverse, the moment we say inversely and inversely as B, we are now having, or inversely as C, we are now having the C 1 over C concept. So this A varies directly as B. But when it comes to C, C is in the denominator, just like this part where we had our B in the denominator. It means we're talking about an inverse. C is the one that is in the denominator, so it's the one that is for the inverse. So we have got two variations that are connected, a direct and an inverse. Here, they were both inverse. Here, both direct. So that is the idea. But at the end, the concept is not going to change. We are going to introduce our constant. So A will be equal to KB over C in this case, where K is the constant to be found. So that is what we have under our joint variation. So it can be one of these. These are the conditions that you're supposed to expect, any one of these. Then the last part is referred to as the partial variation, which is the sum of two parts. We've got the partial variation, which is referred to as sum of two parts. These are the variations that you just need to understand. Sum of two parts. So which concept are we referring to when we are saying sum of two parts? We are considering a condition whereby we can have A is partly constant and partly varies as B, like this. So this constant alone, we are saying it's partly constant. Here, partly varies as B. It's a constant times the variable. If we write it this way, A is equal to HB plus KC, like this. A varies partly as B because we've got a constant and its variable. So it's partly as B and partly as C, a constant with C. In this case, it's partly constant. A is partly constant. We just have a constant without a variable. But the moment we are given partly as B, that means a constant with the B. But just partly constant, it's just a constant there, partly constant. Partly constant, you just indicate a constant, only a constant. But the moment we are saying partly as is the constant, as that variable. So it can be partly inverse to be like this. So it can be direct to be this one, it can be in. So the connection there, later on, we are going to see as we are answering questions. But what I just want you to recap is the basic understanding of your variations, the partial, the joint variation, and so forth, that if you didn't manage to watch the video on the introduction of variation, make sure that you do that, so that at least it can help as we are explaining. So I'm just going to use these variations that we explained to answer our questions now that we are given here. All right, so the first part of our question, we are given that it is given that G varies. So we are supposed to see how are these connected here. G is a variable, M is a variable, R is a variable. There are three variables which are connected. How are they connected? This is a joint variation in this case. So we are talking about a joint variation whereby G to M is directly proportional to M, but when you consider G and R, it is inversely proportional to what? To R. But on a consideration like this, whereby you do not even understand that it's a inverse or it's direct or it's what, you are just given a question like this, the idea is just simply answer the question. When it is a word problem, then on that part we do not have option. But on a consideration, on a condition like this, whereby you consider a question like this one, you know that the first thing that I'm going to do is to introduce the constant to replace the variation sign. So we are given that G varies directly as M and inversely as R. So we are going to introduce the constants. That's the first part. The constant always in the numerator, so it's going to be Km over R like this. All right. This part here is just from the variation that we see here. We are not even considering what we are given later on. We are just introducing, to remove the variation sign, we introduce the constant with the equal sign. So from there now, that's where you are going to determine whatever that you're given. You are given G, M, and R. But the question here is, find the formula connecting. Take note what is connected here. I want us to take note. Connecting G, M, and R. All right, what about this formula that we have here? It's connecting what? This formula that we see, it is connecting G, M, R, and a constant K. If they refer here and a constant K and a constant K that you're given, meaning to say you were supposed to leave your answer at this stage, because that is the formula that has the constant K. But here we can see that K is not mentioned. Our constant here is not even mentioned. So what are we supposed to do? We are supposed to calculate that value of K so that we remain with the G, we remain with M and R. As the letters that we see, it's an equation. The letters that we are supposed to see are supposed to be these ones. This one is not supposed to be seen as a letter. It is supposed to be seen as a numerical value, as a number. It's not mentioned here, so we are not supposed to see it on our answer. So where are we going to have that K? We use the information that we are given here to find the K. So we are given here that G is equal to what? G is equal to 1. So we substitute in this case. So meaning to say the part A now, G is equal to 1. When M is what? M is 2. So this is going to be 2K over R. When R is what? R is equal to 3. Remember, we are supposed to calculate the value of K, which is the constant. So now it's not about variation. It's a normal equation. How do you solve this type of an equation? You can cross multiply, all right? So you can just cross multiply here. 3 times 1, that is going to be 3. 1 times 2k, this is going to be 2k. We divide by 2 both sides. So we are obtaining the value of the constant now, which is 3 over 2. This is our constant, the one that we are supposed to replace here, so that our equation is going to remain with the g, m, and r. G, m, and r are the ones that we are given here. So how are we going to, we are supposed to substitute it this way. G is equal to, in place of k, we're going to substitute 3 over 2 times m over r like this. All right. This fraction does not make sense to have a fraction here and also have another fraction again. So how do you write this part? I want you to understand this part. If you are given a over b like this, all right, which is dividing a certain term, let's consider this as c. If we are given this part here, these denominators can be combined together, meaning to say this is going to give us a over bc. The actual sense was supposed to be like this. You're supposed to have a over b like this, divided to c. C is same as c over 1. You introduce multiplication, a over b times 1 over c. You multiply the numerator, a times 1, which is a, b times c, which is bc. But this actually is a waste of time. What you simply need to understand is that when you are given a fraction to a denominator, the denominator affects the denominator of that fraction. The numerator affects the numerator. So meaning to say here, this denominator, which is 2, is going to affect our r. The numerator 3 is going to affect m. So we are going to have this at the end as g is equal to, instead, it is going to be 3m over 2 is going to affect r. So over 2r. This is a proper way of writing our answer, not to have a fraction and another fraction on top, or a decimal, to have it as a decimal, to say g is equal to 1,5 m over r. We cannot have a decimal then have a fraction at the same time. It's not a proper presentation in our mathematics, and so we have to change in a way that is presentable. So that is, we can check now here. We have G, we have M, we have R. Only these are the letters that you're supposed to have. That is what the question is asking you to do. The formula connecting these variables, sometimes they will ask you as express G in terms of M and R. They are simply asking the same question, or find the equation connecting. In place of this, they will write the equation. They are simply asking you one and the same question. The equation, the formula, express G in terms of. You have made G the subject of the formula. That is to express G in terms of. But they are simply saying, find the formula that connects G, M, and R. So meaning to say you have to calculate the constant, because you are not given in terms of the constant. So like I said, sometimes they'll ask you to write in terms of the constant. Then you have to leave your answer at this stage. All right, let's check the B part. B now, they're saying find the numerical value of G when M is 10 and R is equal to 3. All right, so this one is a continuation. Already you have a formula that is connecting the two of these variables to what? To G. So meaning to say we can simply substitute G is equal to, we have already the part that connects G with M and R. So we are simply going to substitute, because we are given the value of M and the value of R. So it's going to be 3 times M. Our M is 10 over 2R. 2 times R there is what? Is 3. So it's going to be 2 times 3. So that is it. We have the value of G in this case. So you can simplify. G is going to be what? Instead, this is paper 1. So instead of combining these numbers, you can even reduce 3 into 3. 3 into 2, that's 1. 2 into 10, that is a 5. So meaning to say our G is going to give us what? Our G is going to give us a 5. So that is how you can simply attempt a question like this. All right, so I think we understand now the concept of presenting your final answers, which is also another issue on your final exam. All right, P varies jointly. Again, we have a joint variation, jointly as Q. So this is in a direct manner when you are given, like they not mention that it's inverse. It means P and Q are in a direct manner. So we are saying P varies directly as Q. But at the same time, and inversely, the moment we see this word inversely, it's supposed to be 1 over as what? As R minus 3. So meaning to say this is simply, if we multiply Q times 1 over this, is simply R minus 3 in the denominator. So the inverse is in the denominator. The direct, like I said on my introduction, is the one that you write on top. So that is what you're given in this case. All right, let us take our question now. Form an equation. You see the same part here. Find the formula connecting. Now they are saying form an equation. One and the same thing. Form an equation connecting P, Q, and R. Take note the letters that are mentioned here. These are the ones that you are supposed to see on your presentation. So remember, we are supposed to have this as P. We introduce the constant. P is equal to K, Q over what? Over R minus 3. The constant always in the numerator, like I said. So if we check the letters that we have here, we've got P, we've got Q, we've got R, we also have a K. But here it's not mentioned, so you have to calculate that K from where? That is where you take the information that you are given here. You are supposed to make substitution about this information. So there we are given that P is equal to what? To 7. So this is our item A. P is equal to 7. So in place of P, we are going to substitute 7 is equal to our Q, which is 28. So it's going to be 28 times K over R minus 1. Our R there is 6. So it's going to be 6 minus 3. So R minus 3. So it's going to be 6 minus 3 in this case. All right. We are substituting the values that we are given to find K. So we can simplify here. This is 7 is equal to 28K over 6 minus 3, which is going to give us a 3. So we can cross multiply in this case so that we determine the value of K. So if we cross multiply here, we are going to obtain what? 3 by 7, that is going to be 21. 1 by 28, which is going to be 28K. Since you are multiplying here, you can divide by 28 to remove the 28. That means our K at the end is going to be by 7 here. That will be a 3. By 7 here, that will be a 4. So meaning to say our K is 3 over 4 in this case. Remember, we are supposed to leave our answer with the P, Q, and R only. So we are supposed to substitute where there's a K. But remember what I explained before, as you can see here, our K is a fraction. So therefore, we are going to have P is equal to the numerator here affects the numerator. So we are going to have P is equal to 3Q over the denominator affects the denominator. So it's going to be 4 into R minus 3. Because we are supposed to have it as 3 over 4Q like this into R minus 3. We can't have a fraction like this, like I explained before. So the numerator affects the numerator, the denominator affects what is in the denominator. That is how you deal with that type of a question. So simply, that is what you're going to have. Now we have got P, Q, and R only on our answer. That is what we need. That is the equation, or to express P in terms of Q and R. Then on the item B, now they are saying calculate the value of Q when P is 6 and R is 2. So this one is simply a continuation that you are making from the formula that you have already calculated. You do not go back to this formula here. You do not refer back here. You are not referring back to that formula. No, you are from the formula that you have connected between P, Q, and R. It's just a substitution that you're going to do in this case. What are we supposed to calculate? It's Q. Find the value of Q. We are given P. So in place of P, we are given that P is 6. So 6 is equal to 3Q. That is, remember, we are supposed to calculate Q. So it's going to be 3Q over 4 into R minus 3. R, we have the value of R in this case, which is 2. So it's going to be 2 minus 3. So that is the whole idea. You substitute into the formula that you have already calculated for P, Q, and R. Then from there, we can calculate Q. It's a normal equation now. So you're going to have 6 is equal to, right, this was paper 1. So you have to simplify step by step. So we are going to have 3Q over 2 minus 3. In this case, that will be a -1. Remember, 3 minus 2. Then we take the sign of the bigger number. Then we multiply 4 times -1, which is going to be a -4. 4 times -1, that will be a -4 in this case, all right? So we can cross multiply since this is same as over 1. So you can cross multiply -4 and 6, that is going to be -24, which is equal to 3Q. So to find the Q, we are going to divide by 3 both sides. So that means we now have the numerical value of Q in this case. So therefore, Q is going to give us what? -8 at the end. All right, so that was the whole idea about this question. Let's check the other part. We are given that the average expenditure E of a family over a certain period of time is partly constant. We are back now. Partly constant, partly this variation, partial variation. We are back to partial variation. Remember, it said that is where we have got the sum of 2 parts. So here they're saying the expenditure E, so you're given the expenditure E is equal to, all right, so but under partial variation, there is no variation sign. You just write equal to direct to what you're given, all right? So they are saying of a family over a certain period of time is partly constant. So this is the first part, partly constant. Remember what I said on the introduction. Partly constant, it's just a constant that you have. So here you have to check the constants that you are given. Find a relationship between E and N using constants. You are given the constants to use H and K. So where there is a partly constant, you are just going to write a constant. So here I'm just going to write H. If they say partly as, varies partly as, the letter now, that is going to be constant, and the part here they just said partly constant, all right? And, all right, so that's and here. Partly varies as, take note, partly varies as, so it's going to be the constant as that part, which is the number of what? The number of people in the family, which is referred to as N. So it's going to be the constant to the number. Partly varies as. Partly constant, it's just a constant without any variable. We do not have the variable that you're given there. You just write a constant. All right. So what is the first part of our question? Here we are asked, find a relationship between E and N using that is the question. Find a relationship. We are done. So meaning to say the first part of our question, this is what we're supposed to have. So this is the first part of our question. The relationship, that is the equation connecting E and N, but they are mentioning using the constants must be there. All right. Then the item 2, we are given the expenditure for 5 people is $55, and for 3 people it's 45. Find the value of H and K. We are supposed to solve for H and K. Remember, expenditure is represented by E. E represents expenditure in this case here, and N represents the number of people in the family. All right, so here we are given that. Let's take the first statement. The expenditure for 5 people, this 5 is the number of people. So we are given N here, N is equal to 5, is $55. This is our expenditure. So E is the one that we are given as 55. So we have E, which is 55, is equal to H plus N, the number of people, which is 5. So it's going to be 5K. You substitute these values. You move on to another statement, and it's another statement now, this one. And for 3 people, what are we given? N, number of people, that is N. So we are given N is equal to 3, is 400. We are still talking about the expenditure. So the expenditure there is $45. So when E is 45, N is equal to 3. So we are going to substitute another statement again. This time we are saying E is equal to 45. So E is equal to 45. All right. So 45 is equal to H plus N is equal to what? We're talking about the number of people this time being 3. So we are given the value of N as 3 in this case. This is what we are given. So it's going to be 3K, Kn. So it's going to be 3K. So our question is to find the value of H and the value of K. So what are we going to do? We are simply going to solve the variation. The variation only helped us to form this equation here. It is variation. That is where variation ends. Variation ended. The variation part of to say it's partial or it's direct, it ended at this part. That is where our variation ended here. The rest, it's no longer about variation. Here we are talking about if you check how you are putting these values, it's substitution. You need to understand the topic substitution of values, how to just substitute values. After here, you are asked to find H and K. This is not variation. You are given 2 equations with H and K. How do you find the value of H and K? Meaning to say we are back to our simultaneous equations in this case. These 2 equations, they are simultaneous equations where we've got 2 unknown values. So we can simply apply the methods that we know about our simultaneous equations. So by eliminating, here we can simply subtract. We've got equation 1 and we've got equation 2 in this case. So you can simply subtract equation 1 minus equation 2 to eliminate H, since here you can see that H is the same already. So you can eliminate that H. So 55 minus 45, that is going to give us what? That is going to give us a 10 in this case, all right? Which is equal to H minus H, that's a 0. 5K minus 3K, this is going to be a 2K. So revise your simultaneous equations so that you understand what we are doing here. 2 into 10, that is going to be a 5. So I have the value of K. I can substitute this value into any of these 2 equations that I'm given. So I can just even use the first one, whereby we are given that 55 is equal to H plus 5K, which is going to be 5 times K. Our K, we obtained it as what? As 5. So we are going to have 55 is equal to H plus 5 by 5, which is 25 in this case. So we can transpose this value 25 to the left hand side so that we can obtain a negative in this case. So that means we are going to have 55 minus 25, which is equal to H. So what will be the value of H? 55 minus 25, that is going to be a 30 in this case. All right, so our H is going to be a 30 in this case. So we have obtained the value of H and also the value of K. That is the idea. Find the value of H and the value of K. So as you can see, it's no longer about variation. So learn to answer questions now in paper 1. The first part, this is the first item. The first item was just for you to find a relationship straight with N and K. The second part is for you to solve. You are not substituting anything here to say now you have determined your H and your K, you substitute them back here. There is nothing about that part of the question here. The question is find H and K. You end there. That is the idea. All right, let's consider another part, which is got a word problem. So it's not like when every time you see a word problem, it's a partial variation. No, it's not like that. Let us check this one. The number of people N, we are given the number of people is represented by what? By N. So whenever we see N, we see the number of people. I'm just going to write in short here. We see the number of people who favor a certain type of energy drink varies directly as the population size. So this is not a partial variation. It varies directly as the population size S. The population size is S. So S is representing the population size in this case, all right? The population size. So let us have this as a statement. They are simply saying any varies directly as what? As S. Any varies, that is, we are supposed to be given direct like this. But they just want to confuse us, the number of this, who favor this. No. Any varies directly as S. That is what you're given there. So this is the statement. N, which is the number of people, varies directly as the population size, which is S. N represents the number of people, S the population size. So the question here is now, in a population of 1,000 people, only 40 people were reported to favor that type of energy drink. Form an equation connecting N and S. All right, we know that from this variation that we have here, we were supposed to introduce a constant whereby we're saying N is equal to Ks. Direct variation, inverse variation, we indicate the variation sign. Joint variation, we indicate the variation sign. Then we remove the variation sign with the constant. It's only under partial variation where we do not introduce the variation sign, we just write the constants direct. So here we are having N, S, and a constant K, but here they want an equation that connects only N and S. So meaning to say we are supposed to calculate the value of K, from which information we are given here that in a population of 1,000 people, only 40 people were reported. So you have to take note, man. What is it that in a population of? So we are given the population size, we are given S. So this one is the value of S. Only 40 people, the number of people now, N. Remember, I said the number of people, it's N. So we are given S when N is 40. So we are simply going to substitute here. We are given S when N is what? 40. So N here, it's 40. When S is equal to 1,000. So this is going to be 1,000 K. Remember, you're supposed to find K, which is our constant, divide by 1,000. Since you are multiplying, it's now an equation that you are dealing with, remember. So K is going to give us what here? You can reduce by 2 or just by 4, 1 by 4, 4 into 100, that is going to be 25. So K is going to be 1 over 25. But this is not our question. Our question is to find formula, equation connecting N and S. So since we have determined our K, we are going to substitute N is equal to, in place of K, we are going to substitute 1 over 25. So it's going to be 1 over 25S in this case. All right. So this one, you can write it as it is, or like I said, when you are given a fraction, from that fraction concept, the numerator multiplies, you can write it as S over 25, which is one and the same thing, or you can just write it as 1 over 25S. This one is a proper presentation. You can leave it like that. So be careful how you are given your word problems. Then the question on B now is to find the population size S. We are asked to calculate S from which 180 people. 180 people, remember what represents the number of people, it's N. So we are given the value of N in this case. They are saying N, it's 180. N, it's 180. Find S. So we are simply substituting this one from the general formula that we have, or from this equation connecting the two variables that we have. So we are simply going to make a substitution on this part already that we have. Remember, we are supposed to find S given N. So N we are given 180 is equal to 1 over 25S in this case, and we are supposed to calculate this S. So what can we do to remove the 1 over 25? We can simply multiply by 25 because the fraction, whatever you do on the equation on the left-hand side or right-hand side, you do it on the other side. So here we multiplied by 25 so that 1 over 25 times 25, we remain with 1. 1 times S, that is, we have got S in this case. Then here we multiply 25 times 180 in this case. So 25 times 180 was going to give us something like 4,500. So it's a population size of 4,500 people in this case. So that's a population size of 4,500 people. So that is how we play around these questions. It's not like whenever you see a word problem, it's a partial variation. No, relate to the information that you're given. Is it partial or not? All right, then on the other part, the table shows corresponding values of H and V such that V varies directly as H cubed. That is the cube of H, directly as the cube of H. We are given the variation, how these are connected. So simply means from this variation sign that we are given, we can introduce what? A constant. So V is equal to K h cubed. Remember, to remove the variation sign, introduce a constant and equal sign. So here they are saying, find the equation connecting v and h. All right. On this part that we have here, this one, this is from the given information. We haven't started answering our question. This one, we just took it from the given information. We have to introduce the constant. Now the question is to find the equation connecting v and h. This one is connecting v, h, and a constant. So you have to find k. How do you find k? Here you are given corresponding values of h and v, h and v, h and v throughout. So meaning to say, if I substitute whatever part that I want here, if I take the value of h as 1 and v at that moment as 3, I can be able to calculate whatever part that I take. As long you are taking the corresponding part, you can calculate the value of k, which is the constant, so that we remain with the v and h. Remember, our answer, we are supposed to have v and h, not k. So we are going to substitute here. Let's say I take the first consideration here. When h is 1, v is equal to 3. So I'm going to substitute v is equal to 3. H is what? H is a 1. So that's 1 to the exponent of 3 times k. So 3 is equal to 1 to the exponent of 3. That's 1. 1 times 1 times 1, that's a 1. So we are going to have 1 times k, which is k. So meaning to say k is equal to 3 in this case. Okay, let's say I wanted another condition. Let's say I wanted another condition. It's different condition obtaining the same answer. Okay, let's say I wanted to play around with this one. I wanted to use this part. All right. From this condition, what are we given this time? Remember, we are playing with this one. H here is what? It's 2. When V is what? It's 24. So you can just substitute V is 24. So 24 is equal to H. It's what? It's 2. So that's 2 to the exponent of 3 times K. Remember, there's a K that you're going to multiply with. So 24 is equal to 2 to the exponent of 3. That's 8. 2 times 2 times 2, which is 2 times 2, 4 times 2, which is 8. So we're going to obtain 8k divided by 8 by 8. So meaning to say our k is going to be what? A 3. As you can see, we are obtaining the same answer. Even if you apply that to 3 and 81, you are supposed to obtain the same answer of k. All right, so obtaining this value of k, we are going to substitute back now, because this is not our question. Our question is to find the equation which connects v and h. So we are going to substitute now the k into the equation. So v is equal to 3h to the exponent of 3. So this is the formula which connects these two variables, v and h. This is the formula that is going to connect these two variables. Now the question is, find the value of q. Find the value of q. What q is representing? Q is simply representing the value of what? The value of h. This is our h, when v at this moment is equal to 648. So this question was simply supposed to be, find h when v is, that is how they give us in our normal question. Now they give us a table like this. They're just corresponding values. So v is 648 there. H is the one that is represented by q. So you can just calculate h like the normal way, then you know that h is representing q. So in this case, we are going to have it this way. V, what is the value of v? We are given at that moment, v, it's 648, which is equal to 3h. H is the one that we are represented there as what? As q. So we are going to calculate the value of q. Like I said, the variation ends here. Variation ends here. This is the variation. That is where variation ended. The whole of this part, we are no longer talking about variation, solving of equations, substituting of values. So the same thing at this concept. Do not say this is variation. No, this is your normal equation. How do you solve such type of an equation? Think of equations whereby you are given one unknown. What can you do? You can remove the 3 that is affecting q. Since we want to remain with the q, so you can divide by 3 here. That means we are going to remain with the q to the exponent of 3. 3 into 6, that is going to be a 2. 3 into 4 here, that is going to be a 1. Then we've got a remainder of 1. 3 into 18, this is going to be a 6. q to the exponent of, think of those x that we are used to. If you are given x to the exponent of 3 is equal to 8, how do you calculate x? You just introduce the cube root, or you raise to the exponent of a third, both sides from our exponents, whatever way, which represents the cube root of this. Or we are just going to introduce the cube root to remove the exponent of 3. The power of 3, you introduce the cube root. So the cube root of this simply removes the cube that we have on q. So q is going to be the cube root of 216, which is a 6, the number that multiplies itself 3 times. 6 times 6, that is 36, times 6, that is going to be 260. Know your numbers. I said know your numbers before. For exponents, 2 to the exponent of 0 up to 2 to the exponent of 8, you must know it by heart. 3 to the exponent of 0 up to 3 to the exponent of 5, you must know these ones by heart. 4 to the exponent of 0 up to 4 to the exponent of 3. This one from 4 to 5 to 6 to 7, know these ones up to the exponent of 3. From 8, 9, 10, and so on, at least know they are squared. 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. It helps you a lot in exam. You do not now start to find this number and now start to multiply. You start by 2, you start by 3. Until you reach the number that you are expecting to have. It saves you in terms of time, because this is paper 1, so you do not have a calculator. All right. Oh, this one, wow, this one was an advantage. This was paper 2. Oh, so that was an advantage for this one. But in case now, if this type of a question is in paper 1, there you do not have an option. All right. Anyways, let's check the other part of our question. It is given that P varies directly as, in this manner, they wrote an inverse variation as a direct variation. What am I trying to say? Okay, let's see. We are given that P varies directly as t to the exponent of, as it is like this, it's a direct variation. But let's get back to our exponents. Exponents, indices, x to the exponent of minus a represents 1 over x to the exponent of a, which is an inverse. The moment you say 1 over, that's an inverse. So here, this statement could have been written as P varies inversely as, to remove now this 1 over t to the exponent of 3. So this same statement was supposed to be P varies inversely as the cube of t, inversely 1 over as the cube of t, inversely, or in a direct way, the way that we are given there. So these are statements that we are just given. All right, so this is not the important part. What is important is that once you have got your variation sign, what you need is to introduce the constant. So P is equal to K on top over t to the exponent of 3. Here we are not even answering the question, we are just analyzing this statement here. Now we answer the question. Item 1, find the formula connecting P and T. Here from our analysis here, we can see that it's P, T, and K. So we are supposed to find only P and T without the K. So the K is supposed to be removed. So we are supposed to have this time as P. We are given here, we said from P is equal to K over T to the exponent of 3. Our P, we are given the value of P as 4. So 4 is equal to K over T at that moment, which is 2. So that's 2 to the exponent of 3. So meaning to say, we are going to solve to find K. So 4 is equal to K over 2 to the exponent of 3, which is 8, 2 times 2 times 2, 3 times. So that is going to be 8. Then we can cross multiply to find the value of K. 1 times K is going to be K. 4 times 8, which is going to be at 32 in this case. 4 times 8, which is going to be at 32. With the value of K that we have determined, we are going to substitute this K into our equation, the one that we have here on top. But as you can see, we have, okay, this one is direct. Remember, we changed it from that format. I was thinking of that one that we had before. So P is equal to K over this, K over, so our K is what? Is 32. So it's going to be 32 over T to the exponent of 3. So this is the formula that connects our variables P and T together. This is the formula that connects P and T. From this formula now, the question is asking us on item 2, find the value of T if P is a half. If P is a half, we are given now the value of P, which is a half. So meaning to say, we are simply going to substitute now. This is item 2, all right? So this is item 2. So we are going back to our item 2. In this case, we are given the value of P. In this case, P is given as a half, all right? So our P here is given as a half. Find the value of T. So we are supposed to calculate T. So we are simply substituting on the formula that connects the two variables. So that is going to be 32 over T to the exponent of 3. So you're supposed to calculate T from there. How are you going to calculate T? Cross multiply. So you can cross multiply 1 times T to the exponent of 3. That's T to the exponent of 3, which is equal to 2 times 32, which is going to be 64 in this case. Like I said, we are solving equations now. So the question is, how do you remove the cube? We introduce the cube root. The opposite of this is the cube root, both sides, the cube root, or T to the exponent of 3 is equal to 64 from our exponents multiplied by a third, which is the inverse of 3. This the inverse of 64, which is 64 to the exponent of third, which simply means the cube root of 64, as we know from our exponents. So the cube root and the cube neutralizes, we remain with T, and the cube root of 4, of 64, that's therefore I've already stated the answer there, but it's simply the number that is going to multiply itself 3 times to give us the 64. So that's 4 times 4 times 4. All right. So that is how we play around with these questions, guys. We need to just revise as much questions as we can, All right. So let us check the other hand. Here, let us check the other part. But as you can see, it's like now we are just having a repetition, but it's important for us to have this. So this one we are given that it is given that y varies directly as the square. Take note, they are saying the square of. There is the square root. This part is important if we are given as word problems. The square, that's a number to the exponent of 2. The square root, we are supposed to see the root sign. This is the square root of x. So here they want the square to the power of 2, not the square root. Do not confuse. The same with the cube. X to the exponent of 3, the cube root of x. This is the cube root of x in this case, all right? So be careful when you are given a word problem, because they didn't write for you at the one we're supposed to formulate. All right, so it's a direct variation here. Y varies directly as this. So y varies directly. We just said we are just going to write as it is x minus 3, but that's the square of it. So that is the statement that we are given here. All right, take note on item A. Express y in terms of x and a constant k. We need y, we need x. Also, the constant is involved. So here we're just going to write as our item A, y is equal to, we introduce our constant, remember? So we are going to end here. That is our A with a constant. The constant is supposed to be involved. It's different from that one that they say express y in terms of x, only this part. If they say y in terms of x, this part is not there. That's where we have to calculate the value of k. They will give you the information. You calculate the value of k, but here we have the k also on our answer. All right, then let's move on to the other item B. They are now saying, given that y is 16 when x is 1, find y when. Okay, do not be confused now when they ask this way. They just want to confuse you here. You are given first the information, given that this is an information on its own, given that up to this comma here, it says this one, it's an information on its own. Find this, it's a question now that you're given. From what you are given, what are you going to do with this part that you are given? You use this given information to find k. So use the given information to find k. All right, so that is, we are going to give our information to find k. So that is what you're going to do on the B part. Then we find y after knowing k. K is a constant, it connects these variables. So without knowing k, we can't determine any value. We have to find k first. So we are given that y is equal to this part. So y there is what? It's 16. So 16 is equal to k into x. Our x is 1. So it's going to be 1 minus 3 squared in this case. So we can solve 16 is equal to 1 minus 3, that's minus 2 squared times k. So meaning to say we are going to have 16 is equal to minus 2 squared, that's minus 2 times minus 2, a negative and a negative, that's a positive. So we're going to obtain positive 4k. Divide by 4 both sides. So that means our k is going to be a 4. Having the value of k is not enough. This is just a constant which connects our variables. So it means we are going to rewrite now as from this equation that we had, we now have the constant. So that means y is equal to the constant, we obtained it as 4. So it's going to be 4 into x minus 3 squared. So you now have a relationship which connects y and x. They did mention about that. Not mentioning it does not mean you are not supposed to have the relationship. You can't find this without a relationship. So you have to find the relationship first. After the relationship, now you are going to substitute. You are now answering the question, find y when x is 10. So we are going to substitute y is equal to 4 into x. We are given x, that moment is 10. So it's going to be 10 minus 3 squared. That's it. So we are going to have the value of y now, which is 4 into 10 minus 3, that is a 7 squared. So that is y is going to be 4 times 7 squared, that's 7 times 7, which is 49 in this case. So if we multiply 49 and 4 at the end, we are going to obtain something like 196. All right, so y is going to be 196. So that is our question, to find the value of y. But in order for us to find the value of y from this part that we are given, you are forced to find the constant so that we find a relationship which connects y and what? Y and x. Without the constant as a numerical value, after having that constant relationship, that's when we can now substitute whatever that you're given to find now the numerical value of y in this case. All right, then the other part we are given that this case w varies directly as x and inversely as, that is a joint variation. There are two variations. Varies directly as x. Remember what I said on joint variation, w varies directly as x. This is direct variation. And inversely over. The moment you talk of inverse, 1 over, so it's going to be x over what? The square root of x. All right, the square root of u. There is a root here, the square root of u. So it's going to be the square root like this. All right, that is the square root of u. So that is the first part. Here we are asked on item 1, express w in terms of, meaning to say we need x and u, not k. K is not mentioned like this previous part here. And a constant k, that statement is not there. So meaning to say we have to find the value of k. Remember, from your variation sign, you introduce the constant. So w is equal to kx, the constant always on numerator, kx over the square root of u. We use the given information, w is equal to 6 when x is equal to this, and when u is equal to 9. We substitute this information to find the value of k. So there w, it's a 6 when x is equal to 2. So it's going to be 2k over the square root of u, which is the square root of 9. Under variation, the square root of a number is not important, like to say the square root of a number is going to be plus or minus. This part under variation is not important, but under exponents, indices, there we are supposed not even to leave the plus or minus. So we are going to have 2k over the square root of 9, which is 3. So cross multiply so that we can have the value of k in this case. So what are you going to have at the end? 1 times 2k is going to be 2k in this case. 3 times 6, which is 18. So we can divide by 2. We can divide by 2. So that means our k is going to be 2 into 18. That's a 9. So obtaining the constant now gives us a relationship which connects w, x, and express as, it's a formula. Find the formula connecting w, x, and u. That is what they are trying to say. So we have to find the k. After determining the k, we substitute it into our equation. So therefore, our w is going to be equal to, in place of k, we are going to substitute our k, which is 9. So it's 9x over the square root of u. So we are going to have it as 9x over the square root of u. That was the statement. Then on the other part, now we are asked to find w when x is equal to 8 and u is equal to 4. We are now asked to find w. So this one, we are just going to substitute back into our equation, the one that connects the variables, the two variables here. We are going to substitute into this equation. That is, we are given the value of x and also the value of what? Of u. So it's a continuation that you are simply making in this case. So we are saying w is going to be equal to what? Since we have to calculate w, so w is equal to 9x. So that is 9 times x. Our x there is given as 8 over the square root of u, which is 4. So it's going to be the square root of 4. So like I said, under variation, the square root of a number is not that important to be plus or minus, all right? So w is going to be 9 times 8, which is 72. So that's 72 over the square root of 4, which is 2. So at the end, w is going to be 36. All right, so that is the value of w that you're going to have, which is, if you wanted to use plus or minus, I'm not saying it's wrong. You can use the plus or minus. It's not important. It's not that important under variation. All right, so let us check the other part of our question. We are given the wavelength w. So the wavelength is given by w. In this case, is inversely proportional to its frequency. Inversely proportional, that's 1 over. So that 1 over the frequency, which is written as f. So that is what you're given, all right? Meaning to say, in this case, we are asked to find equation connecting f and w. The constant is not mentioned. So here we are going to introduce the constant k over f. Find the value of k. So in this case, our w is given as what? 675. So we're simply going to substitute our value so that we can calculate k. So w 675 is equal to k over f. F it's 90. So how do you find f? You can simply, k in this case, you can simply cross multiply. So 1 times k, that's k is equal to 90 times 675. All right, so there you're going to multiply, but as you can see, there's an advantage of a 0 there. You are going to obtain 60,750. So obtaining k is not enough. We have to substitute back the k now. So therefore, our equation is going to be w is equal to k. We have the value of k, 60,750 over f. These are the variables that do not change, that are going to be changing w and f, where this is a constant, all right? Then b, the value of f. Find the value of f if w is 500. So it's a continuation now that you're simply going to make. W is what? It's 500. Find f. So meaning to say, we are simply going to substitute. Since we need f, w is given as 500. So in place of w, we are going to substitute 500. So 500 is equal to 60,750 over f. So remember, we are supposed to calculate f here. We can cross multiply 500 times f. That is going to be 500f is equal to 1 times 60,050, 750. Then we divide by 500 here. Since we are multiplying, can divide, we obtain our f. So there we are going to reduce step by step. You're going to obtain something like 121,5. So that is the value of f in this case from our given information. So that's variation. We cannot like finish everything, but as you can see, it's just now a repetition of what we have been talking about throughout. It is given that y varies in this case inversely. Y varies inversely as the square root of x, the square root of x. So y varies inversely 1 over the square root of x. All right. So the first part that you are given is to find the equation that connects y and x. K is not even mentioned, so you have to find the value of what? Of the constant. So it's k over the square root of x. We find the value of the constant given the condition here that y is equal to 2 when x is equal to 9. We are going to substitute y is 2 when x at that moment is a 9. So it's going to be the square root of x, which is the square root of 9. So 2 is equal to k over the square root of 9, which is 3. Find k, you can cross multiply to find k. 1 times k, that is k is equal to 2 times 3, which is 6. So having the value of k now, we are going to substitute back into this part that there's a k there. So we are going to have, therefore, y is equal to k being 6. So it's going to be 6 over the square root of x. So we now have the equation which connects y and x. Then item 2, find x now when y is equal to a half. So it's just a substitution, y is equal to a half. Then we are calculating the value of x. So meaning to say in place of y, we are going to substitute a half. A half is equal to 6 over the square root of x. Find x from there. So it's an equation that you're supposed to play around with. Again, you can cross multiply until we have the square root on its own. So the square root of x times 1, that's the square root of x is equal to 2 times 12, 2 times 6, which is a 12 in this case. How do you remove the square root? Remember, all along, we were removing the square. The square of this, we introduced the square root. Now there's a square root. How do you remove? It's the opposite. If we are removing a square with a square root, it means to remove the square root, you just have to put a square. So we are simply going to square both sides like this. The square and the square root cancel. So x is equal to 12 squared, which is 12 times 12. That's 144. So that is going to be the value of x in this manner. All right, then h, on the other part, we are given that h varies directly as the square root of q. Already we are given here as the square root. So h varies directly as the square root of q. Then we are given this information, but take note, they are saying find the formula connecting h, q, and a constant k. That is the first item. So the constant is needed. So h is equal to k square root of q. We are done. That is the first item. Know how to answer your questions. Item 1, we are done. Item 2, now they're saying find the q when h is this. That is where now you will be forced to formulate that equation. You find the value of constant. But where do you find the constant? Always from this information that you are given, where you are given h and q at the same time. H is 51. When q is this, you use this information to find the k. So h is 51. So 51 is equal to k times the square root of q, which is the square root of 289. So 51 is equal to the square root of 289, that is 17, and from 17 times 7, that's 289. Remember, I said you must know those squares. So the square root of 289 is 17, which is 17k. Divide by 17 by 17, so we are going to obtain the value of k. 17 into 51, that's a 3. So having this value of k, we are going to substitute this one. We have to find the formula first. So h is equal to k, which is 3, the square root of q. So we have a formula which connects h and q. Now we can find the value of q when h is 81 from this part now. After formulating a formula from the given information, we now use this h that we have now to find the q. So we are given that h is supposed to be 81. Find the q if h is 81. So we're simply saying 81 is equal to 3 square root of q. Remember, we want to find Q given H. So you substitute what you are given. All right. So how do you calculate for Q? That is the question now. Okay, we can remove the 3. Divide, we're talking about an equation here. 3 into 81, that's 27. All right, 27 is that, so that's a 7 there. 27 is equal to the square root of Q. Remember how to remove the square root, just like the previous part. We said to remove the square root, we square. So we are going to square both sides. The moment we square both sides, we are removing this square root on Q. So we are going to be left with the Q as 27 squared, which is 27 times 27, which is going to give us 729 in this case. So that is the value of Q, which corresponds if H is 81. That is how you answer this question. They want you to formulate an equation first. Without this equation, which connects H and the Q only, we can't determine whatever that you are asked there. So whether they asked you to have that equation or not, you are supposed to have it. So this one is a tempting question because they just give you item 1 to find in terms of A, in terms of K. Then item 2, they just ask you like direct to the question. They are not even giving you stages from there. Whether the stages are given or not, you are supposed to know the stages of variation, to introduce the constant, to find the value of the constant, and then to answer whatever part that you are given. M varies directly as the square of R and inversely as the square root of H. So we have got a direct variation and an inverse. So this is a joint, 2 variations connected together. I say this one is a joint. So we are given that M varies directly as the square. So this one is directly as the square of R. Remember, how do you present direct variation? Inverse is 1 over, so it's the one in the denominator, inversely as the square root of H. So the square root, they are supposed to have the root sign, the square root of H. This is what they are saying. Item 1, express M in terms of R, H, and K. We are just introducing the constant, so meaning to say our item 1, M is going to be K R squared over the square root of H. We are done. We've answered our question. The question is for us to write this in terms of a constant. The constant is involved. So you're supposed to leave the answer with the constant. Then now item 2, find the constant. This is item 2. You are now answering another question. Do not answer as if it's a continuation when it is given stage by stage like this. No. Answer it as it is given. So now you're asked to find K given these values when R is equal to H and is equal to 4. They are simply saying R is equal to 4. At the same time, H is equal to 4. That's what they are saying. R and H, they are equal, also equal to 4. So we are simply substituting M. There is what is 12. So in place of M, we are going to substitute 12. So 12 is equal to K R squared. R, remember, we are told that R is what? It's 4. So it's going to be 4 squared times K over the square root of H, which is the square root of our H, which is 4 again. Remember, these two are the same. So we are going to solve for K. It's an equation now. So 12 is equal to 4 squared, that's 16. K over the square root of 4, which is a 2. That is, we can divide 2 into 16, which is 8. So we are now left with 12 being equal to 8K. So we can divide by 8 both sides since we are multiplying here. So that's we are going to obtain the value of K. So K is going to give us what? Reduced by 4 here, that's a 3. By 4 here, that's a 2. So meaning to say our K is going to be 3 over 2, which is same as 1.5. Or we can have this as 1.5. We can have this as 1,5, whatever part that you have in variation. You can even leave your answer as an improper fraction. Take note, the question was to find the value of K. After finding K, you are done. You're not substituting this anyway. All right. So be careful on how to present your final answers. All right. Then the other part we are given V varies jointly as H and the square of R. So that is V. All this is direct. We are not given anything that is inverse. So it's a combination of 2 direct variations, but giving us a jointly varies jointly as H and the square of R like this. So that's it. That's it. The question is here, write down an equation connecting V, R, H, and a constant C. V, R, and you are given the constant to use. You are not using your own constant. They told you the constant to use. The constant is C. So we are going to have our item A as a V is equal to, in place of that K, we are using C. So it's going to be CH R squared like this. That is what our question is all about this time. You use the information that you are given, where C is the one that is representing what? A constant this time. All right, we are done. We are done. That is the first statement, 1 mark for that. B, now find C given this information. We are now substituting our values, the ones that we are given. So the item B, we are asked to find C given that V is 440. So 440 is equal to C. We are going to find C given H. H is 35. So this is 35 times R, which is R squared. That's 2 squared. So it's going to be 2 squared times what? Times C. So we have formulated an equation that we are supposed to use to find C. So 440 is equal to what? 2 squared. That's 2 times 2, which is a 4. So we are going to obtain 4 here. Then we multiply to 35. So 4 times 35, that was going to give us 140. So 140 times C, which is 140C. To find C, divide by 140, since we are multiplying, divide by 140 in this case. So C is going to give us what? As you can see here, by 2, that's 7. By 2, that's 22. So C is going to be 22 over 7 in this case. All right. So that's how these questions might be like. Some of the times. All we just need is to attempt as much questions we shall see. The next platform or the next chapter or the next part or the next questions that we shall have. But for now, let's revise as much as we can as we are revising for our exams. Let's just try to attempt as much questions. There are so many questions under variation, so many questions, but the idea is the same. It's not like you're supposed to answer all of them. Just know the idea on how to answer these questions. Know the idea on how to attempt each variation: direct variation, inverse variation, joint variation, and also partial variation. There are 4 of them. Each variation, you must know how to attempt it. So if not having this, if still having challenges, let's go back to our variation, each one. Revise each variation, attempt. That is where now you have to attempt it as a separate part. Revise questions under inverse variation separately. Understand how do they ask questions under inverse. Only you move on to another one that is giving you a challenge. As you are revising, you can see, okay, this type of variation is the one that you are not understanding. Work with that type of a variation separately. That's how we can learn this topic also. But for now, that's it. We'll see in our next class.